As soon as we heard the terms heavy metal, it may in our mind that it's dangerous, but do we know what exactly it is? So heavy metal is referring to any metallic chemical element that has a relatively high density and is toxic or poisonous at low concentration. However, there are some heavy metal that we use, for example copper, selenium and zinc, to maintain the metabolism of the human body. But if we overtake it, then it can lead to poisoning. So if it's dangerous, then why we use heavy metal in our product? I would highlight a sentence that I've stated before, which if we overtake it, then it can lead to poisoning. So if we take within the range, then it will be okay to use. So for the first one, we use heavy metal as a pigment in products like toys and others. Other than that, we also use heavy metal as a coloring. For example, iron oxide are common colorings in eyeshadow, blushes and concealers. Next, we have aluminium, which coloring in lip glosses, lipstick and nail polishes.
So we are from Group 3. These are our team members who will be presenting about this case study 1.
I'm going to tell you the negative impact if we overtake the heavy metal. So the first one, I'm going to take lead as an example. So it will cause problems in synthesis of hemoglobin, effect on kidneys, gastrointestinal tract, joints and reproductive system. Also can damage our nervous system. Second one is arsenic, which is it can bind to binding protein and increase the risk of carcinogenesis, which it can cause tumor, urinary bladder cancer, leukemia, prostate cancer and skin cancer.
Okay, so for the next part, we're gonna look into deeper about what is actually the metathesis reaction. Before I go with the explanation, let's watch a simple experiment about metathesis reaction to get an overview about this concept. So, metathesis is a method of quantitative analysis in which the element is swapping ions into a substance that can be separated from the sample. Next, this video is gonna explain on how the swapping ions between solution occur.
Number 4. Double replacement reactions. It occurs when a compound reacts with another compound to form two new compounds. Its general formula is AB plus CD yields AD plus CB, where A, B, and C are different elements or components. Here, D replaces B to form AD, and B replaces D to form CB. For example, the reaction of silver nitrate with sodium chloride. Here, the silver nitrate reacts with the sodium chloride to form silver chloride and sodium nitrate.
And this concept is used in this case study, but we're gonna use argentum nitrate and lead nitrate, which will react with magnesium chloride to get a heavy metal, which is a precipitate after being weighed, filtered and dry.
As we know, the concentration of heavy metals in a product is important, so the concentrations needs to be determined to make sure it doesn't exceed the maximum amount that has been regulated by the NPRA. Thus, a gravimetric analysis needs to be performed on the products that we are studying, which are drinking water and hair dyes. However, there was an unlabeled chemicals in the storage room. In order to continue this experiment, the unlabeled chemicals need to be identified first. The objectives of this case study are we can identify the unknown chemicals using metathesis reaction. Next, we can determine the concentration of the heavy metal in the product. And lastly, which also the most important, is we can determine the safety of the products.
So for these cases, we choose drinking water and hair dye as our product. Throughout the labster, we found out that the HCl is actually magnesium chloride. So in metathesis reaction, we use 100 ml of MgCl solution and 1.0 m of silver nitrate. PB nitrate is mixed in a 250 ml beaker, and precipitate produced is observed and noted. Then the vacuum filtration is assembled and the mixed solution is filtered using a weight filter paper. The precipitate is collected and placed on a petri dish. The precipitate is put into the oven for 12 hours. After 12 hours, we take the precipitation and weigh the mass of precipitate and recorded it.
So, in the Labster, we found that the XCl2 is actually MgCl2. So in this case, we will react the MgCl2 with 1 liter of silver nitrate solution. Firstly, we need to produce the aqueous solution of magnesium chloride, which will get the 0.32 of molarity and 0.1 liter. And then, we need to find the excess reactant and limiting reactant. In this case, silver nitrate is the limiting reactant, which have 3 exponent -7 of mole. Based on the equation, 2 mole of silver nitrate will produce 2 mole of silver chloride. So, 3 exponent -7 mole of silver nitrate will produce 3 exponent -7 mole of silver chloride. From this, we can calculate the mass of silver atom that has in the water. To find the mass of silver, we need to multiply the number of mole of silver nitrate with the molar mass of silver. Then we will get 3.237 exponent -5 gram. Since 1 ppm equal to 1 milligram per liter, we need to convert the gram into milligram. So we will get 0.03237 milligram per liter. The safe value of silver metal in drinking water that have been declared by Minister of Health Malaysia is 0.05 ppm. So this drinking water is safe because it has 0.03237 ppm of Ag metal in the drinking water.
So for the amount of heavy metal in hair dye, when magnesium chloride is mixed with lead nitrate, the outcome will be magnesium nitrate and lead chloride. So if we need to find the mass of lead in hair dye, first we need to know how much is the molarity of lead. After we get the molarity of lead, we can continue and to find the mass of lead. After we get the mass of lead, that is 6.216 milligram, we need to divide it by 0.1 because hair dye only got 0.1 liter. After we did that, we will get 62.16 milligram per 0.1 liter. So the amount of heavy metal in hair dye is 62.16 ppm. So the conclusion for this experiment, mass value of argentum in drinking water is 0.05 ppm. Meanwhile, argentum in drinking water is 0.032 ppm. So the drinking water is safe to use. And for the hair dye, max value of lead in hair dye is 20 ppm, but the amount of lead in hair dye is 62.16 ppm. So the hair dye is not safe to use.